Welcome everyone to my new lecture where we are going to learn about ammeters and voltmeters. If you want to measure what is the strength of the current that flows through your circuit, through a resistor, you use an ammeter. And if you want to measure how many volts a resistor or a battery has, you use voltmeters. Okay, an ammeter is a measuring instrument used to measure the current in a circuit. Ammeters are always connected serial with the resistor where we measure the current that flows through that resistor. So, here we have an electrical circuit. Here you have a battery, here you have a resistor. If you're in Europe, you use this rectangle for resistor. If you're in America for resistor, you use something like this. No, this is this is how you use the sign in electrical circuit if you're in America. I'm from Europe, so we use this. Okay, so the current will flow from the plus to the minus, but you want to see what is the current that flows through this resistor. You have to first cut these two conductors and put an ammeter like this. You draw a circle and put a capital letter A. So this is an ammeter, and the ammeter is going to show what is the strength of this current. Usually it will show you in amps, but it can show you in kiloamps. Kiloamps. 1 kiloamp is 1000 amps. So, for example, if it shows you 2.5 kiloamps, then that's just a second. That's 2.5 times 1000 amps. You can measure it in kiloamps, milliamps, and microamps. That's the basic units. So you have to cut these two conductors and put an ammeter. You can also put ammeter here. It must be in series with this resistor. Okay, so that's that. If you want to measure how many amps you have in your electrical circuit in this resistor, you just put an ammeter next to the resistor in series. Okay. A voltmeter is an instrument used for measuring electrical potential difference between 2 points. We learned in electrical what's a voltage. That's the electrical potential difference between 2 points. And that's voltage, so voltmeter. It measures how many volts you have in an electrical circuit. Voltmeters are always connected parallel with the resistor where we measure the voltage on the resistor. It doesn't always have to be a resistor, it can be a battery like this. So here we have a battery and you want to measure how much volts does that battery have. You put here two nodes and you connect it parallel. And you put this a circle and a capital letter V. That's the sign for voltmeter. Voltmeter. Also, I don't know in America what do you use. And if you want to measure with the resistor, you put two nodes here, and the voltage here must be the same here. So you have a potential difference between two points. Here you have here 1 point, and you have here 1 point. The potential difference from here to here is the same from here to here, also and here. From here to here, from here to here. That's the same potential difference between 2 points. And it's measured in volts. If for example, I don't know, if you have a current passing here, I mean, current passing 10 amps, and you have a resistor that has 2 ohms. With Ohm's law, we can calculate what this voltmeter is going to show. So we have electrical voltage is equal to the current times the resistor. We in America for voltage use capital letter U. If you're in America, you use capital letter V. That's, you know, nothing. And you have next situation, 10 amperes times 2 ohms, and you get 20 volts. So this voltmeter is going to show you that you have 20 volts. Okay, so let's, you know, one more time. So if you want to calculate what the current is flowing through this resistor, you put an ammeter in series. If you want to learn, if you want to see what is the voltage in this resistor, you will put a voltmeter parallel to this resistor. So I say potential difference from this point to this point in this direction is the same as the potential difference from this to this, from this to in this direction. It's the same potential difference, so that's why we put voltmeters in parallel and we put ammeters next to, because here you will have the same amount of electrical current flowing through this resistor and the same amount of electrical current always flowing in this circuit. So thanks for watching and see you in my next lecture.